Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's geometry class. Today we're going to talk about vertical angles. Very, very awesome theorem. Very useful, and you're going to use it just about every single chapter. So might as well learn it right now. In order to really understand vertical angles, we have to understand what opposite rays are. An opposite rays are two collinear rays, that means they're rays that are on the same line, that have a common endpoint which are going in different directions, such as AB here, okay, ray AB, which we'll do in red, bless you, and also ray AC, which we will do in blue. If you notice, my friends, they both have the common endpoint, A, and they're going in opposite directions. That is what an opposite ray is. We've talked about this before, but now we can really articulate it. Okay? AB and AC are opposite rays. And they're collinear, remember that. Now, sometimes you have the situation where you have two intersecting lines. And if you can really identify the rays here that are opposite rays, you're going to have no problem recognizing vertical angles. If you notice here, EF and ED, they're opposite rays, with E as the common endpoint. If you look at EH and EG, those are also opposite rays, with a common endpoint, E. That pretty easy, right? All right, cool beans. Well, if you understand that, then you know what vertical angles are. If you look here, two angles are vertical if the rays forming the sides of one and the rays forming the sides of the other are opposite rays. So angle 1 and angle 2 are vertical angles. Why? Let's think about this. This is one ray of an opposite ray. And over here, this is one ray of two opposite rays. Bless you. So this red ray and this green ray here, which I'm going to attach right here, that forms a vertical angle because they came from two sides of two opposite rays. If you look at angle 1, same difference. You have the red ray and the green ray, which are part of two opposite rays, and the angle they form, okay, is going to be vertical to angle 2. So when angles are across from each other, pretty much they're vertical. But if and only if those angles were formed by the sides of two opposite rays. Now, I do want to show you an example that is not an opposite ray. Let's say I were to give you this, and then I say this, and then I say this. And I say angle 1, 2, 3, 4, and 5. Angle 1 and 5 are definitely opposite rays. But are angle 2 and 3 vertical angles? No. Are angles 2 and 4 vertical angles? No. However, if I said to you angle 2 and the combination of angle 3 and 4, is that a vertical angle to angle 2? Yes. Okay? So remember, they have to be angles formed by the sides of two opposite rays. Now, the easy part. Once you can recognize that, my friends, the vertical angle theorem is simply vertical angles are congruent. Done. Bye-bye. Have a good day. That's it. Vertical angles are congruent. So all you really have to learn here is how to recognize when you have vertical angles. And again, I'm going to repeat it. Vertical angles are only formed by angles that are created by two opposite rays. If you don't have two opposite rays, your vertical angles are non-existent. Just in the example, just like the example that we did here. Okay? Does that make sense? Okay, this is a great example. Angle 1 and angle 5 are vertical and therefore they are congruent. But angle 2 and angle 3 are not vertical, therefore not congruent. Angle 2 and angle 4 are not vertical, therefore not congruent. But if I said to you, angle 2 and the combination of angle 3 and 4, those would be vertical and those would be congruent. Does that make sense? All right. Bless you. Let's check out an example. Given angle 2 is congruent to angle 3. I want to prove that angle 1 is congruent to angle 3. Well, angle 1 is congruent, angle 2 is congruent to angle 3. That's given. What can you tell me about angle 1 and angle 2, y'all? They're congruent. Why? Because they're vertical angles. Vertical angles are congruent. And now that I know that angle 2 is congruent to angle 3 and angle 1 is congruent to angle 2, what can you tell me about angle 1 and 3? They're congruent. Why? Transitive property. Boom. Done. Does that make sense? It's very, very powerful. Vertical angles and transitive and substitution, very powerful, very useful. They shorten up a lot of potentially very long proofs. May I continue, my brothers? Awesome. Okay. Angle O is complementary to angle 2. Oh, that would help, huh? Give me 1 second. All right, I apologize about that. That is totally my bad. Let's go ahead here, and this would be angle O. Kind of hard to do a proof without the labels. That's M, that's K, that's H, and that is J. And again, I do apologize. That is my fault. Okay, so angle O is complementary to angle 2. That's given. Angle J is complementary to angle 1. That's given. Being that those are O and J are complementary to 2 and 1, what do I know about 2 and 1 right now? They're congruent. Angle 1 is congruent to angle 2. Why? You could say, in this case, very good. You have two choices here. You could say complements of the same angles. Well, wait a second. No, you don't have same angles here. No. Vertical angles, period. They didn't say that O is complementary to 1 and J is complementary to 1. Then that would have proved that O and J are congruent. Here what we said is that angle O is complementary to 2. Angle J is complementary to 1. But now I do know that 1 is congruent to 2 because of vertical angles. So now, how can I prove that O is congruent to J? Think about this, guys. If O is complementary to angle 2, and J is complementary to angle 1, and 1 is congruent to angle 2, thank you. O is congruent to J because complements are congruent, angles are congruent. Didn't we just prove that 2 and 1 are both congruent? Guys? So doesn't that mean that O and J have to be congruent because they're complementary to congruent angles? Again, if you don't understand that, put numbers. Let's say that angle 1 is 30 and angle 2 is 30. If O is complementary to a 30-degree angle, O is 60. If J is complementary to an angle that's 30, J is 60. So wouldn't that mean that O is congruent to J? So its complements of congruent angles are congruent. We're going to be using all of the proofs throughout the year, my friends. We're not going to just cut off a proof. Okay, so please try to remember that. Does that make sense, y'all? Do you need me to do it again? Because I will. We're good? All righty. Let's continue. Last but not least, If angle 4, the measure of angle 4 is 2x plus 5, so we have here the measure of angle 4 is 2x plus 5, and angle 5 is x plus 3 plus 30, I want to find angle 4. Well, what do I know about angle 4 and angle 5? Why are they congruent? Vertical angles. So we've got 2x plus 5 equals x plus 30. Subtract x to both sides. X plus 5 equals 30. Subtract 5 to both sides. And we've got that x equals 25. But that is not our answer. I want angle 4. So angle 4 will equal 2 times 25, which is 50, plus 5, which is 55 degrees. Does that make sense? That's it. That's our lesson. Hope you learned a lot. Have a great day, and thank you very much.